Good morning, ladies and gents. Let me make sure this thing's on. We're golden. E-learning day 2. It is probably Tuesday morning by you. Monday morning by me. Got the kiddos with the in-laws. We're gonna rock out a little bit of bearings on day 2. Make sure that you guys are communicating with us just about, hey, that didn't make sense in Mr. Ernst's video. Email Ms. Fulling or Mr. Moore or myself. So that we can address it in a video in days future. So quick notes today. If you noticed, day 2's only got one problem. So first, I'm actually going to take you through number 2 from yesterday's homework. And so they say that 2 towers are on a north-south line. From tower A, So you'll notice that in the homework, or in the notes from yesterday, I kind of draw small little drawings to kind of get my bearings, no pun intended, straight before I draw the whole picture. So from tower A, the ship is located at a bearing of 247 degrees. So 0, 90, 180, 270, so it's going in this direction. So 247 would be, let's see here, 67 degrees past that 180, okay? And from tower B, so here's gonna be tower B, the ship is 300, has a bearing of 327 degrees. So 0, 90, 180, 270, 327. So that's going to be from 270, 327 will also be 67 degrees. So the reason I wanted to do that, this is not going to work because all my action is going to be happening over here. So I am going to get rid of that line. And tower A has to be north of the ship. Tower B has to be south because you can see that the ship is right there. Okay, so we're going to redraw this in a manner that you guys can see. With B, we're headed in this direction. We calculated it so that this angle is 67 degrees. Now this is super huge right here. Alternating interior angles. We know that these 2 lines are parallel. And so that also has to be 67 degrees, okay? From tower A, it is headed down, and this angle was 67 degrees, which means that alternating interior angle has to be 67 degrees because, again, those 2 lines are parallel. We can ditch this picture now, okay? Now the question asks, find the distance between the towers if the distance from A to the ship is 2,572 meters. So we know that that guy is the ship, and we know that this line is 2,572 meters. Okay? At this point, we want to fill in any angles that we know. Okay? And so we do know that we are focused on this 90 right here. We've used 67. We have 23 degrees left over there. We've used 67. We have 23 degrees left over. Okay? And now I'm going to take this mess and I'm going to redraw it like that. A, B, ship. And 2,572, 23, 67, and 23 plus 67 right here is 90. I need to find the distance from A to B. I have a right triangle again. I'm trying to find X, okay? If I use this 23 degree triangle, or 23 degree angle, I should say, I can just use opposite hypotenuse sine So sine of 23 degrees is equal to 2,572 over x. I'll multiply both sides by x, and I will divide both sides by sine of 23. Mr. Ernst left his calculator in the basement, so Miss Fulling has this on the answer key. I don't remember what it is, but your answer comes from that right there. Make sure you're in degrees. Hopefully that makes sense. I think the biggest takeaway from this is alternating interior angles, okay? So anytime that you have these two pieces, they're gonna alternate. And then my second piece of advice is, when you're here, maybe redraw it as just a regular triangle without all the extra lines in it, just to make it clear a little bit. Okay, I'm gonna grab a paper towel while you collect your thoughts, and we're gonna do the one homework problem that we have, or notes problem that we have today. So it's a little different doing teaching in my kitchen, but I hope you guys are all staying safe, and a piece of tape up there to keep the board up, staying safe and virus free. All right, day 2. A sub leaves a port at a bearing of 220 degrees. Okay. So again, we're going to draw a small picture here before we draw our official picture here. So there's port, sub leaves at 220 degrees, 0, 90, 180, aha. Headed down in this direction. If it's a bearing of 220 degrees, that's 180, so we're 40 degrees more, okay? It says for 80 kilometers. So we know that it's going there for 80 kilometers. It then travels at a bearing of 100 degrees for 60 kilometers. So this is a big piece. Okay? It stops right here. We're going to recalibrate. Okay? We're going to redraw a new north-south, east-west axes because we're about to turn, and we're going to turn at a bearing of 100 degrees. So 0, 90, aha, 100. So we know we're just a little bit to the south of east, and we are headed for 60, and these are in kilometers, okay? That's all the information they give us. They ask, on what bearing and how far should the sub travel to return to port? Okay, again, we want to recalibrate ourselves, and this dotted line is going to represent what we need to find. Okay, they're asking us 2 questions though. They're asking us the distance of that dotted line and also the bearing. We'll talk about both in just a second. I actually got a little bit lucky here with this picture. I don't think I have to erase it. I think you guys can see that. Let me check real quick here. Yeah, that looks like it's big enough. Sorry, the iPad's resting on the laptop, so you'll have to bear with me when I tilt it down. Okay, so we're gonna fill out our alternating interior angles here. So this guy has to be 40 degrees coming from that because these 2 lines are parallel, okay? Which means that this angle right here, since there's 90, this has to be 50 degrees, okay? Because 40 minus 90, 50 left over. This little guy right here is 10 degrees because these 2 lines are parallel, so we have alternating interior angles, okay? And, that's about all we know, okay? I do believe. So now is where I'm going to redraw it. I have this triangle here. I know that that is 80. I know that that is 60. and I know that this is 60 degrees. I got 60 because it is 50 plus 10, okay? So the easy part is finding the length of that dotted line. We have a triangle and we have side, angle, side, okay? So we're gonna use the law of cosines. I'm gonna call this guy X, and I'm going to say X squared is equal to 80 squared plus 60 squared minus 2 times 80 times 60 times cosine of 60 degrees. Okay, and I'm going to have to run into the basement to grab my calculator. I'm sure that a couple of you are laughing at this point. That's okay, I'll be right back. You crunch those numbers while I'm gone. Eli, do you have it? I am crunching 80 squared plus 60 squared minus 2 times 80 times 60 times cosine of 60 degrees is 5,200. Do not forget to square root that. And when we do that, we get about 72.11 kilometers. So 72.11 kilometers is the distance here. Now notice that the setup is the only new part. All the rest of this is just the law of sines, law of cosine stuff that we've been using. Now, we need to know what the bearing of this line is. Obviously, the sub is traveling in that direction right there. And so we're kind of worried about this angle right here, okay? So let's try to find this guy. Sorry, I kind of wrote over it, but let's call it big B, okay? In order to find big B down here, this angle, we're going to use law of sines. These guys and these guys. So we'll shift up here. We'll say sine of 60 degrees over 72.11. That pair is equal to sine of B over 80. Now bear with me. I know Ms. Folling flips this over. It's the same thing because we're about to cross multiply here. So don't freak out if you have this exact same fraction except everything is flipped. We now have 80 sine of 60 degrees divided by 72.11 is equal to sine of B. And so we are going to inverse sine, that's in the wrong order. We are going to inverse sine all of that. And when we do that, inverse sine of 80 sine 60. I feel like we should know what sine 60 is. What is that? Root 3 over 2. 80 sine 60 divided by 72.11. That's inverse sine. And I get 73.9 degrees. So B is equal to 73.9 degrees. Now, is that my answer? Is that my bearing? The answer is no, it is not. I'm going to fill it in right here. My drawing is not phenomenal because that angle looks much smaller than 73.9, but either which way, they need to know what the bearing is. So we have two options, okay? We can either use the bearings like they gave us in problem number 2 from homework last night, 0, 90, 180, 270. If we did it like that, it's going to be 0, 90, 180, 270 plus 10 plus 73.9. So almost due north, okay? we're going all the way around this, that would be 280. So one of these answers, okay, is going to be 353.9 degree bearing, okay? So that would fully answer our question, okay? They asked on what bearing and how far should the sub travel to return to port? On a bearing of 353.9 degrees for a distance of 72.11 kilometers, okay? The other thing that you could write is, some of you prefer doing the north of east and so on and so forth. We have to refer to north or south in those two instances, and so we would be saying north, and then how far to the east, we'd have to find that. That turns out to be 6.1 degrees west. And these two bearings are exactly the same. Okay, so you don't need both of them, you just need one or the other. It looks like a lot on the board there. Hopefully that helps. I think biggest thing, like I said before, other than alternating interior angles, keeping yourself organized, maybe redrawing a new triangle so that you don't have all of the extra stuff in there. But hopefully you guys are safe and happy and virus free. Talk to us, let us know what we can do to help. And hopefully we'll see you guys sooner rather than later. Adios.